try this one now. We're going to integrate 2 minus x divided by the square root of 2x squared minus 8x plus 1. We're going to find the antiderivative of this function. All right, so there's a lot going on here. So usually, as we've seen, what's helpful is to just try and separate the parts of this function. So we have a fraction. Try to separate this into the different parts. So we'll write this instead as the integral of 1 over the square root of 2x squared minus 8x plus 1 times 2 minus x dx. So again, this is kind of a strategy. If you see a function and you're not quite sure where to go, kind of separate it so you can distinctly see the different parts of your function. So it's helpful. It's not always necessary, but it can be helpful just to separate the parts of the function. And that's what we're doing in this kind of step here. We're just kind of going through the thought process for how you might do these, if it's not immediately obvious. So once you get the hang of these, you'll probably be able to pick out u right away. All right. So we have a root function and we have a fraction. So let's first rewrite this root function with a negative, or with a fractional exponent. So I might write this as 2x squared minus 8x plus 1 raised to the 1/2 power with 2 minus x dx. And when we look at this, this does look like we have a fraction of the 1 over something form, but there is this exponent here that kind of is being applied to the entire denominator. And so if we're gonna integrate this thing, and that's what we're trying to do, but if we're going to integrate this thing, when we have raised to the power 1/2 here, that's not going to involve natural log. So it's not quite this form here. We can rewrite this with a negative exponent. So that if it was just 1 over 2x squared minus 8x plus 1, then we would let u equal the denominator. But because there's this 1/2 here, we're going to go a little bit further, and we're going to rewrite this with a negative exponent to get rid of the fraction. So if we do that, we're going to have 2x squared minus 8x plus 1 raised to the negative 1/2 power times 2 minus x. All right, so we've done a couple things here. When we see a root sign, we rewrote it with when we saw a square root sign, we rewrote it with a fractional power raised to the power 1/2. And then when we see this fraction, we used a negative. We made the exponent negative to get rid of the fraction. And so now what we see is we have this kind of complicated looking expression, but it's all inside of a power function. It's this 2x squared minus 8x plus 1. It's inside this set of parentheses. So yeah, there is this other term over here that's inside parentheses, but generally we kind of focus in on the more complicated of the two pieces. So let's actually go through, now that we've rewritten this, let's actually go through the integration. So we have it rewritten as 2x squared minus 8x plus 1 raised to the negative 1/2 power times 2 minus x dx. And so we have our different parts, and we normally start with the more complicated of the pieces. So I would say this is the more complicated. We also have this 2 minus x, but I would think this is the more complicated. And so if we see parentheses, Normally what happens is we let u equal the inner function, what's inside the parentheses. So step 1, what are we going to pick for u? Well, that 2x squared minus 8x plus 1. It's inside the parentheses. Okay, not too bad. Now we calculate du. So let's differentiate this thing. 4x minus 8 is the derivative. And then we multiply that entire thing by dx. Okay. So now we want to kind of plug this in. We want to start substituting our things in. And what we look is this complicated piece is kind of spoken for. We know that's going to become, it's going to involve u. We need to figure out, well, what's going to happen with these leftover terms, this 2 minus x dx. And so we go to our, what we have for our differential, and we want to compare. So we want to compare this. And if you're not seeing an evident match here, it doesn't look like it really matches, try factoring this. So you can try factoring until you see something that does match. So really what we're trying to do is we're trying to see, is there a 2 minus x in here? So let's see what happens. So if I factor, I can factor out a 4. There's a 4 here, and then there's a 4 in here. So I could factor out a 4. So I have 4 times x minus 2 dx. And that's looking better. Here I have a 2 minus x. Here I have an x minus 2. The only thing different is the order. So if I multiply both sides of this equation by a negative, by -1, multiplying by -1 would reverse the order. So if I multiply both sides of this equation by -1, I'm going to end up with negative du on the left. And then the -1, I would just distribute it into the parentheses here, and it just switches the order. So I'll have a 2 minus x instead. And now we're looking, this is looking pretty good. The only thing is I have a 4 here, and I don't have a 4 up here. So this 4 is an extra constant. So we do what we normally do with extra constants. We move them to the other side. So I'm going to multiply both sides of this equation by 1 over 4. So that's going to give me 2 minus x dx all by itself on the right. So I'm going to end up with negative 1 over 4 du is equal to 2 minus x dx. And now we see this is a perfect match for what we have. And so we'll be able to plug this in. So this will become negative 1 over 4 times du. So sometimes there's a little bit of work we have to do in order to get these differentials to match all nice with the leftover terms that are there. All right, so now once we've done that, that's the hardest part. Now we can start fitting our pieces in. So this complicated piece, that's going to become u raised to the -1/2. The 2 minus x dx, we said, well, what's 2 minus x dx? That's -1/4 du. So we're going to have -1 over 4 du. And now we have just a nice power rule problem here. So the -1/4 is a constant multiple, so I'll just put that first. And then we focus in on getting the antiderivative of this u raised to the -1/2. So our variable is u. I add 1 to the exponent, so that's going to bump me up to +1/2. So I'm going from -1/2 up to +1/2 if I add 1. And then I take this new exponent and I flip it. So I'm going to put a 2 over 1, or just 2, right there. And then our customary plus c at the end. And we've integrated our new integral. So we're done. We have the antiderivative. The only thing left to do now is simplify and then convert back to x. So I would simplify this, and it's usually helpful to try to simplify first. So the 2 times 1/4 simplifies to just a negative 1/2 there. And now I can plug back in. So I end up with negative 1/2. And then my u term here, u, is this 2x squared minus 8x plus 1. So we can fill that in. And that's raised to the power 1/2. And then we have our plus c. And there we go. We have our antiderivative. So when we have these fractions, don't forget, and root functions, don't forget about rewriting the root function as a power function, and then even rewriting the fraction with a negative exponent. And then we also saw sometimes the differential, it takes a little bit of work. So you might have to try factoring, or try playing around with the differential that you calculated to kind of match up, to get it matching with the leftover terms in our integral. All right.